everyone caught up after today? We did part 1, that was 1 page, and part 2, that was 1 page. And I feel like you got those. Okay. So that's right after that.
Pencil?
No, we had that work day on it, so. You're so tired. Can you take them out of your backpack though? That's a good place for them. And good prospects.
Alright, so to start trigonometry, let's talk about our 3 ratios that we use. So what is one of the ratios? The ratio we normally start with is sine. So whenever we say sine, it's S-I-N-E, but when we abbreviate it, it's just S-I-N. We use that theta just for an angle. And for sine, it's what over what? Opposite over hypotenuse. Okay, and then we have cosine. And cosine is what over what? Good. Adjacent over hypotenuse. Miss Slider just talked about these, which is great. Otherwise, flip back if you're getting lost. And our last ratio is tangent. We just do T-A-N for tangent. And again, that little circle with the slash through it is just a Greek letter. Instead of using x, we're just using theta. And how do I find tangent? Good. Opposite over adjacent. So to help us remember this, we think of SOHCAHTOA. And it just abbreviates it for us so that we can see each part a little separately, but it's going to help us identify pretty quickly which ratio we want to use. So for this first one, we know it's sine, so I'm going to start with S. And sine is what over what? Opposite O over hypotenuse. So that's where SO comes from. Then we're going to do cosine. So cosine is C, and cosine is what over what? Adjacent over hypotenuse. So SOHCA. And then for tangent, it's T is opposite over adjacent. So we're going to keep that in mind. In my last couple of years when I taught geometry, if I gave out worksheets on this stuff, people would write SOHCAHTOA at the top of the worksheet. That's the first thing they wrote. So it just helps you remember, or helps you identify faster which one you're going to use. Okay, so for our first set of problems here, we're going to find the missing side lengths. So you can go ahead and take out your glue stick. You don't need to cut at all. But you are going to glue this in, and you don't need to cut at all. You can just go straight into cutting. I'm sorry, straight into gluing, no cutting. No cutting, just glue.
Make sure you have the right side up, though, to check that your helmet is upside down, and you'll be all kinds of confused today.
So you shouldn't need to cut them. Should be able to just glue it all in. Okay, today we are going to use our Desmos calculator quite a bit. So if that's something that you feel like you can have on your computer while you don't focus on anything else on your computer, just the calculator, you might want to have your calculator open, but if that's too much for you to handle, then that's okay. You don't need your calculator open. We'll do it together for now. Okay? So go ahead and get that food in. Should be pretty exact. You were off a little bit or cut a little bit off. Try cutting it close. It's so sharp. Alright, here we go with that first example. Okay, these three we just kind of put all as number one, but there's actually three. What? I'm gonna write below it. Yeah, just like that. Okay, you got it. Okay, and I'm gonna show my work underneath the problems, but I'm gonna just kind of do 3 columns here because these are each a little bit separate from each other. How we do them is going to be really similar, but we're going to do each one a little different. Okay, so we're going to focus on this first one here. Okay, 35 degrees. That's this angle here. What do we call that angle that we are looking specifically at? Good, the reference angle. So this is our reference angle, which means that's how we're going to decide which ones are opposite, hypotenuse, and adjacent. I always start with opposite and hypotenuse. That's easiest for me. Adjacent is kind of the goofy one that I have a tough time with that I always leave till the end. Okay, so what side is opposite of 35 degrees? Opposite is 16, yep. Hypotenuse, I look at my 90-degree angle, and I go across from 90 degrees. So here's my hypotenuse, which means my leftover side is adjacent. So the ones I have opposite is 16, and I'm looking at this hypotenuse of x. So I have O and H. So if I think back to SOHCAHTOA, if I have O and H, am I going to use sine, cosine, or tangent with opposite and hypotenuse? Yeah, it's the so. I'm going to use sine. Good. So on this problem underneath, I'm going to write sine. And remember, it does look like sin, but we call it sine because it's really S-I-N-E. We're just too lazy to write the E. And then what is the angle measure? How much is the angle? 35, so we're going to put the sine of 35 degrees equals, and then I want opposite over hypotenuse. So 16 over x. No. All right, do we like the variable on the bottom of a fraction when we solve? No. In chapter 7, we talked about that a lot. Where do we like that variable to be? On the top. But to do that, we want these to both be ratios. So what could I put sine of 35 over? Yeah, over 1. Can always put something over 1. So now I can flip both sides. So I'm going to put x over 16. But if I switch that side, I have to switch the other side as well. So this is going to be 1 over sine of 35 degrees. Okay, now my goal is to get x by itself. So how would I undo a dividing by 16? Multiply by 16. If we do it on one side, do it on the other side. We get x equals. Now this is the part where we're going to use our calculator. You don't know what the sine of 35 degrees is. I don't know what the sine of 35 degrees is. I'm sure I was taught once upon a time to memorize it, but memorizing is not the most fun thing in the world. So we use our handy dandy calculator. Desmos is a really great use for this. So we're going to use our calculator, and over here we have 1 divided by, and we're going to use sine of 35. So sine is right here. Sine, and it puts in parentheses for us. So we want just the 35 degrees, just the angle in there. And then I'm going to go off to the side times 16. And we are going to get a decimal for most of these problems, and that's okay. Let's round to the nearest tenth today, so just 1 decimal point. So do I want 27.8 or 27.9? Good, 0.9. So x is 27.9, and it's a side length, so we could label it units, or we could just do 27.9. And that's our x. So that's a way that we can find a missing side of a right triangle when we only know one side and we only know one angle. Okay, let's try the next one. Again, we're going to look at our reference angle of 30 degrees. That's this angle here. I'm going to put in that little arc there, but does that mean that this angle is congruent to this angle? No, normally we use it for that, but this is a completely different problem. It's just on its own. It's just telling us that's where we're looking. That's our reference angle. So our first step is to always label the 3 sides: opposite, hypotenuse, and adjacent. Okay, which side is opposite of 30? X. So that's opposite. I put OPP there. Kind of hardly see that, sorry. Which one is my hypotenuse? The blank side, yep. Which means what is my adjacent? 13. So which 2 sides are we dealing with? Our opposite with the x and our adjacent with the 13. So O and A. So I'm going to go back to my SOHCAHTOA, or I can just think of sine, cosine, and tangent. And I want to know which ratio deals with opposite and adjacent. Good, tangent. Tangent is OA, it's TOA, or it's opposite over adjacent. So we're going to use tangent. So that's the next thing that we're going to use, is that idea of which one we're going to use. So we use tangent. And for tangent, we just do TAN because we're lazy. We don't want to write tangent every single time. That would just take up too much of our lives. And what is the angle? 30. And then I have that ratio. Do I want x over 13 or 13 over x? Why do I want x over 13? Because it's opposite over adjacent. It has nothing to do with the x necessarily. It's that the x is the opposite over the adjacent 13. What's going to be the really, really big difference when I solve this one compared to the one we just did? Yeah, do we need the 1? Do we have to flip it? No. If we don't need to flip it, then we don't need the 1. The 1 is only there in case we need to flip it. So in this case, we just have to get rid of that 13. And how would I undo a dividing by 13? Multiplying by 13. Because dividing and multiplying, what do we call those things that undo each other? You guys remember what is something that they undo each other? They're blank operations.
We talk about multiplying and dividing, or adding and subtracting.
Inverse operations, good. All right, so in this one I'm going to do tangent of 30, so I'm going to use that tangent, and then 30, and I want to make sure I close off my parentheses, because it's just 30 is just the angle, but then it's times 13. Now we're going to keep that 7.5 or round up to 7.6. The 0 tells us to stay at that 5. So x is 7.5. Nice. All right, first step on the next one is we're looking at that 34 degrees. I don't know why these all were in the 30s. Just so happened. I don't know. Didn't notice it until after I printed it. Nuts. Go ahead and label your sides. So which one is opposite, which one's hypotenuse, which one's adjacent. Label those yourself. See if you can do that or do a quick self-check. Step number 1. Label your sides. So when you look at this, what is 12? Is 12 the opposite, adjacent, or hypotenuse? Good. 12 is the hypotenuse. What is x? Adjacent. So we're going to use adjacent and a hypotenuse. I always label opposite. The reason I did it this time is because I was just asking you. And how many of you labeled opposite when knowing we weren't going to use it though? Think it's okay? Yeah. Good. Okay, so we have adjacent and hypotenuse. So between SOHCAHTOA, which one has an A for adjacent and an H for hypotenuse? It has to have both those things. Good, cosine. So we're going to use cosine because it has both an A and an H. So we're using adjacent and a hypotenuse. So cosine of, what's the angle? 34 degrees. And cosine is A over H, adjacent over hypotenuse. So what is adjacent? Adjacent is x over our hypotenuse, 12. Okay, and then how am I going to solve that equation? Multiply by 12 on both sides. Good. So again, you aren't going to do this by hand, cosine of 34. You're going to use your calculator. I'm going to show you on your phone calculator, those of you with iPhones. I know not all of you have iPhones, so this might not be super helpful. If you have an Android, let me know, or Google or whatever we call those other phones. Androids, right? Is that what we call them? Let me know and I can show it to you sometime. I just got to play around with it. So if you're going to use your phone on your calculator, you need to tilt it sideways, which means it has to be unlocked. So if you just go to your calculator from your lock screen, you have to unlock your phone to let it tilt sideways. And then you're going to type in 34 first, the degree, 34. And then we type in cosine, and cosine is right here. It's almost on the last one. On the very last row, it says cos H. We're going to make sure we just use the cos. Okay, so cosine. And then times 12. And that would give us 9.9 or 9.5. Or I'm sorry, 9.9 or 10? 9.9, yeah. Okay, I find that really hard to do on an iPhone. I know that you guys probably think I'm just saying that because I'm your teacher and I'm like, use Desmos because that's my job. Okay, but really using Desmos is going to be the easiest way to see if you're doing it correctly. So cosine of 34, parentheses, times 12. That's going to be the easiest way to make sure that what you're doing when you see it, that you did it right. On your calculator, it's really hard for you to see if you typed everything in correctly. All right, Miss Sawyer is going to pass out one more sheet. I'm going to paste this on the next page because I'm going to run out of space here. It's going to take about the same amount of space as this one. So if you only used half your page, you should have enough space for this. But if you only have like a third left.
This is also slightly different. This is finding missing angles. So if your brain wants you to organize it by putting two separate pictures, then go ahead and do that too. You can even label it angles. Other one side.
I'm going to go on to my next page and label that missing angles and then glue that in.
So we're going to set this up the same way. So if you want to draw those little lines between, you can go over. Do that.
I'm going to write SOHCAHTOA at the top of my page here since I started a new page. If you're on the same page, maybe don't write that again, or you could write it underneath the problems. But again, that's just our quick reference to know if we're going to use sine, cosine, or tangent. It just helps us look at and identify without having to read all those fractions. Okay, I'll give you about 30, 45 more seconds to get ready, and then we'll get started. All right, let's label this triangle. Let's label this P, R, and Q. P, R, and Q. So which angle is going to be the reference angle in this problem? P, Q, or R? R. So we're going to label those sides according to R. We start off the same way we did before, where we're going to say our opposite, our adjacent, our hypotenuse. I'm going to just shorten it to O, A, and H. If you need to write OPP for opposite, do that, or ADJ for adjacent. I'm just going to do O, A, and H. So which one is opposite of angle R? 2. So that's going to be my O. What is the hypotenuse? Yep, the part across from the Q. We don't know that, so that's our H. Which means our adjacent is 5. So I have my opposite and I have my adjacent sides. Those are the two sides I'm given. I need to find the angle measure of this angle. So using O and A, is that SO, CA, or TOA? Which one is opposite and adjacent? TOA. So we're going to do tangent. So I'm going to write tangent of angle. What was our reference angle? R. We just named it R. You could put a question mark there if you want. Just normally we do put a letter there. So tangent of angle R equals, what is my opposite? 2 over my adjacent 5. Now our goal here is to get R by itself, just like how our goal before was to get X by itself. So I want to get R all alone. What's on the same side of the equal sign as the R currently? The 2 is on the other side. What's on the same side of that equal sign? The tangent. We have to undo a tangent. And we talked about that. What do we call those operations that undo things? Inverses. Good. So we, in the math world, we're not creative when we talked about this. We do the tangent inverse. To get rid of a tangent, you do tangent inverse. You undo the tangent. Mind-blowing, I know. What that looks like is we do a tan. We write out that word that we're undoing. So it could be sine, it could be cosine, but in this case it's tangent because that's our tangent there. And then to show that it's the inverse, we do like an exponent with a -1. So a little -1 off to the side. And that tells us that we're going to undo that tangent. And then we'll be left with just the r. But if I do that to one side, I have to do it to the other side. So now on this other side, I'm going to do tangent inverse, that's that -1. And I'm going to just carry down that fraction that we were using. What fraction did we have? 2/5. I'm just pulling that down. So this is the part that I'm going to put in my calculator. Okay, now there's a couple ways for you to do this. I'm going to show you first on Desmos, and then once we get to like the last example, I'll show you on your phone calculators. On Desmos, what I like to do, the way I was taught was always to go to function here. So it's actually a different menu. So there's this main, ABC, and then func. So you hit this function, and then there's these inverse ones. So tangent inverse, and then I would type in 2/5 using my keyboard. Okay, so that's one way of doing it, is by going to that menu. Another way of doing it is if you're still on the main and you want to stay on this, you can do tangent, and then you have to click in front of the parenthesis, in between the parenthesis and the tan, and we can do an exponent of -1. So you can type in that -1 if you want, and then 2 divided by 5. Whichever way is easiest for you. For me, I like to stick, it just is easier to just hit that tan -1 already, but that's your choice. So this is going to be 21.8, and this is an angle, and all angles have a certain way of measuring. How do we measure all angles in what unit? Degrees. All right, let's go to this next one. Let's call this M, N, and K. Trying to stay away from our opposite, adjacent, and hypotenuse. So this problem, it almost looks the same as the one before it, where the right angle is in the same place. But this time, what's our reference angle? M. So we're going to do things according to this angle. So from my M, I like to always do my opposite first. Opposite is across. So here's my opposite. You can do an O or an OPP for opposite. My hypotenuse is across from the 90. So I'm going to start at my 90, go across, get my 49. Which leaves 33 to be what side? Adjacent. So the two sides I have adjacent and hypotenuse. So if I have adjacent and hypotenuse, should I use sine, cosine, or tangent? Which one uses adjacent and hypotenuse? Cosine, it's the ka. Good. Okay, so cosine of angle M. Again, you could put a question mark there since that's what they labeled it as, but normally we like to put the letter there. Is it going to be 49/33 or 33/49? Good. Adjacent over hypotenuse, AH. So A, 33 over my hypotenuse, 49. And our goal is to get M by itself. So what do we have to undo that is with the M? Cosine. How do we get rid of cosine? Yeah, like what we did last time. Does anyone remember what we call that? Inverse. So we just say cosine, and then that -1 we say inverse. So we do the cosine inverse. And we undo cosine. Sometimes, I swear, like mathematicians like to say things super confusingly, and then we do things like this, like, how do you get rid of cosine? You do the inverse. Alright, so cosine inverse. And then we have our fraction here. This is the part that we're actually going to put in our calculator. 33 over 49. And then we're going to put that in our calculator into our Desmos. So again, you can type in cosine, but then you have to go back and make sure you put that -1. Or you can do func, which stands for function. And we want that cosine with a -1. And then I just use my keyboard to type in 33 over 49. Little slashy slash. All right, and now we're going to get 47.6 or 47.7. 0.7, good. And again, this is an angle, so we're going to label it 47.7 degrees. Now, last time we weren't super official. We just said R equals. This is an angle, so remember we want to do that lowercase m and that angle sign.
That's the measure of angle.
So that measure of that angle is 47.7. All right, last one that we're going to do as notes, and then we're going to do a couple as practice problems all together. Okay. Let's label this C, B, D, BCD, CBD, DBC, DCB, all the things. So we're going to find angle D. So go ahead and label your sides according to angle D. If you want to just think ahead, if you're not somebody who wants to write down in case you have to erase, think, are you going to use sine, cosine, or tangent? So look at your sides. Try and decide what you're going to use. So using angle D, what are the two sides we're given? Opposite and what? Hypotenuse, the 15. So if I'm given O and H, opposite and hypotenuse, is that so, ka, or toa? That's so, that's our sine. So we're going to say sine of D equals, what is our opposite over our hypotenuse? 15. How do we get rid of sine? Sine inverse. Good. It's that sine with that -1. It just tells us we're going to get rid of that sine. It's now gone. But if I do it on one side, we have to do it on the other side. Good. So on the left side, that sine is gone. I'm left just with D equals. Okay, if you do this on your phone, big thing is with sine, cosine, and tangent on your phone is you have to put in the thing first and then do that sine, cosine, or tangent. So I'm going to first put in 13 divided by 15. I have to put that in first. 13 divided by 15. I'm going to hit equals, so that gets me a decimal. Now, for sine inverse, it's nowhere on this part here. You have to hit this second menu because there's not enough buttons here for all the buttons a calculator needs. So on your phone calculator, there should be a second. And then down here is the sine inverse, cosine inverse, tangent inverse. So you need that -1 in there. So I'm going to do, do we do sine? Sine inverse. So we get 60.0 or 60.1? 60.1. So if you're using your phone calculator, 1, I wouldn't recommend it, but 2, you actually have to do the inside of the parentheses first in your calculator, then hit that sine inverse button. If you're using Desmos, which is 20 million times easier, you just hit that sine inverse button, and then 13 divided by 15. And it tells you the same answer. Okay, if you have an Android, you should see that second function. I think there you can like pull over if like you swipe, you see that. But I highly, highly, highly recommend using Desmos. It's just going to make your life 20 million times easier to be able to see what you're typing in. It makes it way easier when Miss Swider and I come and see if you got your answer right, if you got your answer wrong, where you made a mistake.